5, 4, 3, 2, 1. Nope. Hey folks, Nathan here. We had our V0.5 Hydron launch the other day, and as you can see, it didn't go how we'd hoped it would. Our parachute didn't deploy, so we had a pretty hard landing, parts went everywhere, which we'll get into a bit later. So let's diagnose what the issue was and how we're going to fix it in the future. So we're partway through designing our V0.5 Hydron, and what we've done is we've modified our payload bay, so you can see that we've now got a bit of cardboard in the bottom and a cardboard bit at the top here. What we've done is we've just traced out the area, cut out the cardboard, and we've just used some Loctite or super glue to just glue these in. So these are pretty solid now. What we've done at the top here, we've got our nose cone just attached on one side by essentially just a little hinge. And on this side we've got a bottle cap which we've glued on, which we've got this hairband attached to currently, but we'll probably change it to something with a bit more elastic strength to it. So it's going to sit down here. We're going to have our servo down here which will release, and once it releases the nose cone will fly off. It obviously didn't in this case because there's no air rushing past, but like this thing will, with the slightest nudge, the nose cone will just come flying off. Mainly because we've got that high center of mass on the nose cone here, so any force is just gonna nudge it over there. So hopefully this should be solid enough to then do that. Our parachute will come out and all should be well. So next up we need to fill up this payload bay. So we'll be doing that by getting our electronic system done, building a small little PCB, and yeah, we'll be putting in an Arduino Nano for our calculations and our processing. We'll be doing a BMP 280 barometer for our altimeter, and then we'll be having our servo in there to manage our nose cone separation events. And finally we'll have a button so that we can actually reset the state, and of course our 9-volt battery to actually power it. So that's where we're at currently. Let's dive into some electronics. So the original plan for the Hydron V0.5 was to have a BMP 280 altimeter, as well as the servo motor and the Arduino Nano, so that we could record altitude data and have an altitude-based parachute release. But, so this is the little PCB that we tried to make. This here on the back is the absolutely atrocious soldering job that was done. And for some reason the BMP 280 just straight up doesn't want to connect to the Nano. It worked on the breadboard well enough, but on this not at all, which I'm guessing is due to the terrible soldering job. So rather than just straight up throw this out, because it's kind of useless at this point, I'm just going to attach the servo to it and make it a timed parachute release with the Nano, and just sort of ignore all of this bit here. I'm going to throw an LED on so that I can see from a distance when the timer is starting, so that I know when to pull the cord. And yeah, that should be pretty good. So yeah, while we don't get to use the 280 on this, and the main board itself is sort of pointless, rather than throwing it out, we're going to try and salvage it and at least get some useful thing out of it. So yeah, we should be able to see if the parachute deploy mechanism that we've thought up here will actually work, and a timed release will tell us that just as well as an altitude based one will. So next up we had to put everything into the payload bay of the rocket. So on our left we have our servo motor, in the middle our 9-volt battery case with our on-off switch, and on the right our circuit board. So these were all attached in there with Velcro strips and a bit of tape where necessary, and this worked pretty well at holding everything in together. Due to the complete lack of sensors on our circuit, we used a pretty simple timing mechanism to launch the parachute. So first off, we'd press the button, and that would give us a 5-second window until the countdown started. At that point, we had a 5-second countdown, which was indicated by flashes on an LED, and then once we got to the 5th flash, we'd pull the rope, it would launch, and then 3 seconds later, the servo would go off and the parachute should deploy. So let's take a look at the launch and see how that actually worked in practice. Okay, 5-second timer starts now. Launching in 5, 4, 3, 2, 1. Nope. Well, here's the remains of our rocket. It just nosedived into the ground, as is tradition. Wow, the LED went through that somehow. So this top plate's just slammed down. Wow, that is impressive. Alright, well, clearly something's not connected anymore because this isn't turning on. It could just be the LED. But yeah. Alright, well, I'm not sure what happened there, so we'll review the footage and see what's up. As we can see, no parachute came out, timer didn't work apparently, and it just crashed into the ground. So looking at the launch, it was pretty much here where the parachute should have deployed. Unfortunately it didn't, and we can see that the entire way down the nose cone is still on. But fortunately it made for a good cushion when the inevitable crash happened, so most of our internal components didn't end up too damaged. So we did do a pad test before the launch itself, and that seemed to work pretty well. You can see here the 3-second timer is about to go off and the servo releases. So everything there worked as intended, and in theory the nose cone should have come off during flight as a result of this. So because it didn't, the leading theory is that the servo itself didn't deploy. After some time doing some diagnosis, I think the most likely culprit was these 3 wires here. So these are what connect to the servo via this plug, and one of these wires I'm quite sure came out just after launch. So because obviously these are a very mechanical connection, they can pull out quite easy. Like I'm putting barely any force in and this is just coming out. So these were just held on with masking tape, and masking tape did not do a good job of actually holding those wires in. So I think next time we're going to just cut the wires to the servo and just solder it directly onto the board, just so that way we're not going to risk any loose connections. One of the changes that we'll make is to make our parachute deployment mechanism a lot more reliable. So currently, the way that we do it is we have this part here, which when we pull it down and release it, provides elastic force, which should knock this off. But as you saw from the test, it wasn't very reliable. It didn't knock it all the way off. It typically only come off a little way. So what we'll do is attach a stronger elastic band to the top of the nose cone itself and run it down the opposite direction of this one. So then we've always got this elastic force trying to pull the nose cone off, but this is what will be holding it down. So that way when the servo releases, the entire nose cone should just fly off from this top elastic force rather than trying to rely on this flicking up enough to actually push it off. So one final thing that wasn't accounted for was that with the added weight of components, so the 9-volt battery, the circuit and the servo, the flight time was around 5 seconds compared to the 6 seconds it normally is. So because of that, we have to adjust our timings accordingly. And that's it for this video. I'm hoping for the V0.6 Hydron we will have the BMP280 ready and working, as we've ordered a new one and hopefully that'll show up. If not, we'll be doing another timed mechanism and just hoping on a more reliable servo connection. Alright, catch you later.